Now we came to the one of the most famous rule, L'Hopital rule. So this rule is basically applying derivative to the limit problems when we have indeterminate solutions like 0 over 0, infinity over infinity, infinity minus infinity, 0 times infinity, 1 over infinity, 0 over 0, infinity over 0. So we are unable to evaluate these values, right? So when we have these solutions, as we solve our limit problems, we can take derivatives of both numerator and denominator separately, and it will not affect the limit. So as you can see here, we can actually take the derivative of both numerator and denominator, and it will not affect the solution for our questions. So let's look at this example. Here we have when limit x goes to 0, cosine 2x minus 1 over x squared plus 2x. So as you can see here, when we put 0 instead of x, let's see what is our solution. So this is with cosine 0. Cosine 0 is equal to 1, right? It's 1 minus 1 over x squared. It is 0 squared, which is equal to 0 plus 0. So as you can see here, we get 0 over 0. So we are unable to evaluate this. Now we can do what we can do. We can take the derivative of numerator and denominator. So let's do that. When you take the derivative of this numerator, so cosine 2x. What was the derivative of cosine? It is sine, right? So it is sine. So here it's minus sine, of course. It's minus sine 2x. And also we should take the derivative of 2x, which is equal to 2. Okay? Over minus 1, its derivative is equal to 0. That's why I don't need to write that. Let's take derivative of this one. So it is 2x plus 2. Now let's put 0 instead of x. So here we will get minus 2 times sine 0 over, this is 2. So this will be equal to 0 over 2, so which is equal to 0. As you can see, this didn't affect our limit problem, and all you need to do is to take derivatives of the numerator and the denominator. Let's continue with this example. Here we have limit as x goes to infinity, 3x times sine 5 over x. So let's put this infinity in front of instead of x here. So here we will get 3 times infinity. It is infinity times sine 5 over infinity. So this is when it on the limits, this is equal to 0, right? So here we get infinity times 0. But to apply L'Hopital rule, you should have fractions like infinity over infinity or 0 over 0, okay? Because you will take the derivative of numerator and the derivative of denominator separately, and then you will be able to find the solution for your question. So how can I rewrite this expression in order to get some fraction like this or this? So as you can see here, we have 3x times sine 5 over x. So I can write this x as a denominator. How? So I can write this as limit x as x goes to infinity, okay, 3 times sine 5 over x over 1 over x, right? Because when you do this, it's actually the same thing. You just write this x as 1 over x and as a denominator, okay? And then after that, let's find this limit. So this is when you put this infinity in, instead of x. So when 5 over infinity, it's equal to 0. So it is 3 times 0 over 1 over infinity. It is 0. So this is, as you can see, 0 over 0. Okay, now I can use my L'Hopital rule. Okay, so let's do that. How I do that? I take the derivative of the numerator and the denominator separately. Okay, so here we have 3 sine 5 over x. So its derivative would be 3 times, what is the derivative of sine? It is cosine, right? Cosine 5 over x. And then I will also take the derivative of 5 over x. So 5 over x, I can write this as 5 times x to the power of minus 1. So when I take its derivative, it will be minus 5 times x minus 1 minus 1 minus 2, right? So this will be minus 5 times x to the power of minus 2 over 1 over x. So how I can find its derivative? 1 over x, I can write this as x to the power of minus 1. So I put this minus 1 in front of x. So it is minus x to the power of minus 2, right? Minus 1, it's equal to minus 2. So this is equal to minus x to the power of minus 2. Now, I have here x to the power of minus 2, so I can these can cancel out each other, and I will cancel these signs, and from here we will get 3 times 5, it's 15 times cosine 5 over x. Yes, we don't have anything in the denominator, so this is our solution. So from here we are not over yet, so we will put now we will put infinity instead of x here. So let me write it like this: limit as x goes to infinity. So here, when you put infinity instead of x here, this will equal to 0. So this is 15 times cosine 0. So cosine 0 is equal to 1. That's why it is 15 times 1, which is equal to 15. So this is the answer for our example. Horizontal and vertical asymptotes. So remember that an asymptote is a line that the graph of a function approaches but never touches, okay? So rational functions also contain asymptotes. Let's say our function is equal to px over qx here, okay? This is something like, for example, y is equal to x squared plus 2x over x squared plus 5x minus 6. Okay, this is something like this. When our function is a rational function, as here, you should know that it contains asymptotes. So vertical asymptotes are vertical lines which correspond to the zeros of the denominator of a rational function. Can we have a zero in the denominator of a function? Of course not. So if I set this denominator of this fraction equal to 0, and so this will tell me the values that x cannot be. That's why it goes like this but never touches, okay? So in this graph, for example, it is a. That's why fx goes very close to a, but it doesn't touch that vertical line. It avoids the vertical line at the point of a, okay? So let's look at this horizontal asymptote. So this line, this line of f of x, this line will never go under this limit. So how can we find this horizontal asymptote? So to find the horizontal asymptote, you should find the value of the limit as x approaches infinity for the function of f of x. Okay, f of x. So this is the formula you should know for the horizontal asymptote. Let's solve an example, one example, and you will understand better. In this example, we have find the vertical and horizontal asymptotes of y is equal to 3x minus 5 over x minus 2. Now first, I know that the value makes the denominator equal to 0 is our vertical asymptote, right? So let's do that. X minus 2 is equal to 0, so x is equal to 2. So this 2 is our vertical asymptote. This is our vertical asymptote, okay? So how do we find our horizontal asymptote? We will take its limit. So limit as x approaches to infinity, 3x minus 5 over x minus 2. Okay, so this is equal to, this will be, when I put infinity in front instead of x, it will be infinity over infinity, right? So we cannot evaluate this, that's why I will use L'Hopital rule, right? So how we do that? We should take the derivative of denominator and the numerator separately. So this 3x minus 1 and its derivative is equal to 3, right? And x minus 2, its derivative is equal to 1, so it's 3 over 1, which is equal to 3. So this 3 is our horizontal asymptote. So when you draw its graph, it will be something like this. So when x is equal to 2, this is our vertical asymptote, and when y is equal to 3 here, this is our horizontal asymptote. Slant and curve asymptotes. So a slant asymptote occurs when the polynomial in the numerator has one more higher degree than the polynomial in the denominator. Okay, to find the slant asymptote, you must divide the numerator by the denominator using either long division or synthetic division. And a curve asymptote occurs when the polynomial in the numerator has at least 2 more degrees than the polynomial in the denominator. Let's continue with these examples. In the first example, we have y is equal to x squared minus 1 over x plus 3. So as you can see, this function has a slant asymptote. Why? Because the numerator has 1 more degree than the denominator. As you can see here, its degree is 2 and the degree of denominator is equal to 1. So this function has a slant asymptote. So how we can find this? We can do the long division. So let's do that. It's x squared minus 1 divided by x plus 3. So let's multiply this by x. So from here we will get x squared, it's plus 3x, okay, so it's minus, this will cancel out. So from here we will get minus 3x minus 1, okay, and then I will multiply this by minus 3. So it's minus 3x minus 9. So from here this will be equal to 8. So this is our slant asymptote, okay. So this is our slant asymptote. So we can write this as y is equal to x minus 3. So when you draw its graph, it should be something like this. Here is 3, so it will be something like this. Of course, this is a line, and I couldn't draw very well, but this graph also should be like this. Okay, it's very simple. You just divide, you just do the long division, and the quotient here gives you the slant asymptote. So let's look at this example. Here we have y is equal to x to the power of 3 plus 1 over x. So as you can see here, the numerator has 2 more degree than the denominator. That's why this one has a curved asymptote. So we will do the same thing, long division. Let's do that. X cubed plus 1 over x. So this would be x squared, so x cubed. And then here we will have, yes, only x cubed. And then from here we will get 1. So as you can see, this is y is equal to x squared. This is our curved asymptote. Okay, asymptote. Yes, asymptote. So this is our curved asymptote, and how it graph looks like. It looks like something like this, right? When x squared, its graph looks like this. So as you can see, you first look at their degrees, and then you will decide either it has a slant asymptote or curved asymptote, and then you will do long division or synthetic division, whichever you want, and then that quotient gives you the equation of the asymptotes. Now let's look at this example. Here we have f of x is equal to x squared minus 3x minus 4 over x minus 5 to the power of 2. So let's find its graph here. So first we know that the value that makes the denominator equal to 0 is our vertical asymptote, right? So which value makes our denominator is equal to 0? It is 5. So let's look at here. We have 5 here, we have 5 here, we have 5. And we have also 5 here, so we actually have 5 in all choices. Okay, let's continue. Let's give x, let's say x is equal to 0. So when x is equal to 0, our function will be equal to, this is 0, 0, minus 4 over 0, it's 5 minus 5 squared, it is 25. So when I give x 0, I will get y as minus 4 over 25, right? So let's look at this value. So let's say here we have, when x is 0, y can be minus 4 over 25. Why? This can be go like this, and then it can pass through minus 4 over 25. So D can be our choice. So let's look at here. So here when x is 0, yes, y can be equal to minus 4 over 25. When I look at here, when x is 0, I don't have any value on the negative side of y. That's why we can eliminate this choice, because there is no value on the negative side of y line. Okay, because I know that when x is equal to 0, y should be equal to minus 4 over 25. That's why I can eliminate this choice. So let's look at this one. Here we have when x is equal to 0, here I have minus y value. That's why this can be also our choice. So let's continue. Now I eliminated the choice A, and then we will look at B, C, and D. Okay. Now let's give 0 to the y. Okay. If y is equal to 0, then this numerator has to be equal to 0, right? So x squared minus 3x minus 4, which is equal to 0. So here x, and here it is minus 4 plus 1, right? Yes, it's minus 4 plus 1. So it is x minus 4, x plus 1 is equal to 0. As you can see, when y is equal to 0, x can be 4 or x can be minus 1. So let's see. Here, when y is equal to 0, okay, we have 4, but we don't have minus 1 here, so we eliminate the choice D. And here we have, when y is equal to 0, x is equal to 3 and x is equal to minus 1, but we don't have here 4. That's why we also eliminate this one. And as you can see here, when y is equal to 0, x is equal to minus 1. And x is equal to 4. So that's why B is our correct answer.